So I just checked with you, Margarita. I hope you are able to see my screen.
Yes.
Are you?
Yes.
Yes, but the recording is not yet started. Okay, now it's good. Go
Thank
for
you.
it.
Hi.
Give me 10 seconds to arrange my windows here. All right. So yeah, I'm ready. Welcome everybody. If even I can't see you guys, I'm pretty sure you are there. We are here today to talk about, I believe, a quite known topic, which is unit integration testing. Look, I try to put the accent in this presentation on the business importance of it, because I believe, well, we believe in the Agile world that even though it's pretty much, development-centric topic, it must be of importance for business as well and for management, for some reasons that I will try to explain. Just a little bit of a disclaimer. In nature, it is a technical topic, okay, because it's born by a technical need. But I will try to make it digestible for everyone in order not to bore people that maybe are not technical at all. So I hope to succeed at that. And in case, the question and answer session are there for that reason. So before starting, just a couple of words about ARHS, which is the company I'm working for. It's a group of entities, actually, that has already 17, 18 years of growth so far. We are almost 2,000 professionals, so that 1,700 figure is even outdated today. We are even more than that, so it's a big, big group. And we are experiencing a lot of growth, even lately, even in these weird days of isolation. So it's a very, let's say, maturing group that is growing year by year. We are 13 entities. Actually, it's one company, but divided into 13 entities, distributed a little bit all over Europe. Here included Portugal, Italy, Greece, Luxembourg, of course, and Belgium as well. Why I have bolded ARHS Spikeseed? Well, because that's the entity I'm working for. And ARHS Spikeseed is located in Belvoir in Luxembourg. And if you want, we are, let's say, well, the innovative part of ARHS, I would say, because we're focusing on the last trends. Especially we are certified for many cloud providers, such as AWS and Azure. So we can offer expertise in cloud, in machine learning, of course, in software development, which is a big part of our work as well. And we strive for basically for giving our customers the opportunity to get results as early on in the process as possible. That's why we push the boundaries for agility as well, which is one of our field of expertise. Just a few words about me. I'm Davide, okay? So I'm working for ARHS since 2011. I am project director here. I am also the Agile coach for projects in ARHS, so cross projects in ARHS. I also am experienced in coaching external companies a little bit throughout Europe, I would say, when it was possible, of course. Now we are, deviating a little bit more towards the remote coaching, even though it's not as effective, of course, but we are doing quite well in that regard as well. As agreed with Margarita, I'd like to have some inputs from you guys before starting in order to get to know you better and possibly to try to amend and tailor the presentation depending on the answer that you will be giving. We will be asking these three main questions. I leave the word to Margarita for that because we have a poll for you.
On your screens, you should be seeing a square now, a rectangle in which 3 questions are listed with different options. When you scroll down, you see the rest of the questions. There are 3 in total. Please choose the option that best suits your background and your domain of expertise and your level of familiarity with the concept of unit and integration testing. We will leave it open for a couple of minutes, so everyone has the chance to give their input. And Davide will really benefit from the information, so please take a minute and participate.
Yeah, I see answers flowing in.
I see that too, great. We have a very interactive audience today.
But Margarita, I can see just the first question actually. Is that normal? Yeah.
When you scroll down, you should see the rest of them.
Oh, that's
Right, please.
okay.
If you scroll down, yes, you will see question 2 and question 3. Yeah.
Okay, that's good. So yeah, as expected, there is a majority of IT.
That's the remaining 12 people to see if this majority remains or not.
Yeah. So we have some developers here, mostly managers, business.
And everyone is not so new to the concept as we thought. That's great. I will leave it open for another half a minute, and then we'll use the results.
Quite a useful tool, actually. It's integrated in Zoom.
Yes.
Okay, cool.
Maybe leave it more because I see that some new joiners are also joining the conference. I would say as it is between lunch break, we could have some late joiners. So I think that we can leave it open, I would say, by enhancing also the results.
I do not think the newly joined participants see it because my number of participants in the poll does not change.
I have 30, I got 28 before, but yeah.
Yeah, we can leave it for 5 minutes. I think it's feasible.
Hello and welcome to everyone who joined us now. Can you see the poll with the questions on your screen?
So maybe, but for the time being, we can just at least comment the first feedback.
Yeah. You want me or you do?
Yeah, go ahead.
Go ahead.
Yeah, I was just looking at it and it's quite expected. There's a majority of information technology professionals, someone from engineering and construction, quite a lot of manufacturing and public services. Okay. I was expecting more finance, but okay. So yeah, majority of IT. So we talk more or less the same language. Then we have, what's your domain of expertise? A lot of management as expected. So I believe, just tell me if I'm wrong, mostly project managers, I guess. Some developers, which is very good, 4 of them, and 1 business. Was expecting more business actually. No HR. How familiar are you with the concept of unit integration testing? Someone master it? 2 people. I know what it is, 13 persons. I heard about it, 9. And unit and integration, what? 1 person. So yeah, sincerity.
More if we were allowed to vote.
What is that?
It could be more if we were allowed to vote, but since we're hosting, we cannot vote. So I would be in the last group, count me in.
So I think you can continue to get your presentation.
Yeah. I don't think I don't see the answers moving. Okay, cool. Thank you for that, guys. It's very useful to me. So yeah, back to us. Wait a minute. Technical problem. Here we go. Look, before getting into the topic, let's talk about testing in general. Testing is an integral part of our daily activities, I would say. Not only job related, but even when you're doing some do-it-yourself bricolage at home, you of course test what you're doing, or think about, I don't know, an actual job such as the bricklayer, okay? It's basically inconceivable to have a bricklayer doing his job of piling bricks to build a wall and not testing what he's doing. It's just a natural, approach that he continuously tests, for instance, that the bricks are not broken, or that they are aligned with each other. Think also about a surgeon, maybe that for sure he's gonna test that the bisturi is cutting as it should, and that is sanitized. In IT is the very same actually, only that it's more complicated than that. Of course, it's IT. So we have a hell of a lot of different type of tests. We have performance tests that are taking care of the fact that the application may be performing like expected or not. Stressing tests, we have system tests, we have end-to-end tests, which are very important. Actually, they are those that are also called user tests because they put the application to the user point of view and the whole flow is tested. And of course, we have unit and integration tests, which is what we're going to talk about today. Before starting, a little bit of an agenda, just to let you know where we are at any point in time. We will be introducing what is a unit in a very general manner. Then what do we mean with integration? Why is that? Because even today, I do believe that there's a kind of confusion about what a unit and what an integration is, even amongst professionals, amongst developers. After that, we are going to explore why. Sorry, Margarita, I have my sharing poll window that keeps coming. I don't know why.
And that was not me.
Yeah, no, because these are the final results, I guess. Okay, let me just put it. Okay, good. So we're going to explore why unit and integration testing are actually important and critical to the success of any application. Then we are going to introduce two concepts that are probably new to you, probably, I don't know, but they are quite related to the topic of unit integration test, which is technical debt and refactoring. Then a little bit of a word about when it's better to start unit and integration testing. We will go through, probably this is a little bit more the more technical part of the presentation, but I will try to stay high level. We are going to explore some best practices that every developer should put in place when doing unit integration testing, and then a little bit of recap, okay, to see what we have learned today. So starting, what is a unit? As I said, even amongst professionals, among developers, sometimes there is a little bit of a confusion. So try to think to the unit as the smallest component that it makes sense to test. Forget about IT for a moment and think about a big complex system such as maybe a car. A car is made of systems and subsystems. Think about the engine, think about the electrical system. And every system is made of smaller units, okay? Each of these units, no matter what, probably has some specifications and requirements that it should comply with. Think about, for instance, the crankshaft, okay? Probably the crankshaft has some requirements behind it. Who says that the crankshaft is supposed to, I still have this window coming on. Let's close it, okay? The crankshaft is supposed to rotate a number of times per minute, and it has probably a given length. Or think about the fan, the radiator. It has probably the requirement to be spinning, okay? Because if it is not, it just loses its nature. Think about the pistons. They are supposed to have a junction, and this junction is supposed to be loose in order that it can be integrated into the crankshaft. Or even simpler, think about the tailpipe. At least you have to be sure that the tailpipe is not obstructed. Similarly, in IT, a unit is a very simple piece of logic in this case. It can be a method, for instance, a very simple method that is answering you with the result of a division. So a method that is expecting two inputs, two strings. It's supposed to divide the first string by the second one, okay? And then it's supposed to provide you with an answer, with an output. So if the unit is the smallest testable component, let's say, what is the integration and why is it necessary? Well, integration happens when you take all those units, think about the car again, and you bolt them together into the assembly line, okay? If you do so only unit tests and you don't take care about integration tests, okay, you may face the situation where the driver gets in the car and the car doesn't start. Or maybe it starts, but it doesn't move, okay? If you didn't do integration test, which means if you didn't take care of the fact that components should work with each other, it will be very difficult to actually hunt down the problem. And it will be immensely more complicated to understand where the system is failing. So basically, integration happens when you take the unit and you make it made part of a bigger system. Visually, you can see at that this picture shows very clearly 2 unit tests that are working because the drawer is made as per specifications. It has a handle, it has a size, but when you put it together, it doesn't work. Makes no sense. You can't open it. Or take a look at that. Here you have a lock, which is working, so it has been unit tested. You have a handle and you have a door, which is sliding. It's also working because it's sliding. But does it make sense? This is a system that is faulty because the components are not working well together. Last and final example, which is more embarrassing, so I won't go into the details here, but yeah, this is also quite speaking. So, why do we need unit and integration testing? Well, let's try to put it as simple as possible. Unit and integration testing, it is something supposed to test the unit and the integration between them. So they don't misbehave and maybe potentially cause problems in the visible part of the application. So they are quite low level, development centric, but they will affect the way the application behave to the end user. I invite you to think about, unfortunately, tragic episode back in 1986. Think about the shuttle, which was a wonderful machine, even though today it's dismissed. It's a very complex machine. I mean, we did the example of the car, but a shuttle is way more complex than that. Back in that morning of January 28, one of the rubber rings, which is no different than the rubber ring that you have in your household tailpipes, which are supposed to prevent water from leaking, okay? That rubber ring, one of them failed. And basically, what happened is that the lateral boosters got poisoned with the fuel from the main tank, and then the whole machine went boom. So we can say here that such a complex machine, such as a shuttle, failed because of such a simple unit. And we can say that the quality of a system, any system, no matter its complexity, it's no better than the quality of the least tested unit. That is why unit test and the integration between units, they are critical for any system. Basically here, the shuttle entered production, and production was seeing it failing at launch. And it costed the lives of 7 persons, if I'm not mistaken. But you may ask, okay, that's right. So unit integration tests are there to prevent bugs from happening. Okay, that's the final goal of them. So how they are different from any other test? How they are different from regression testing or, who knows, end-to-end testing? Well, you know, the big difference is that the added value of them is that they are super integrated with the development process. And they are quick and fast, and they help developers to identify bugs, meaning unexpected behaviors, as soon as the code is modified. That is the big advantage they have. The feedback loop is very short. I invite you to take a look to that to this statistic, and this statistic is a real thing, and it shows the cost of bug discoveries differently in time. You can well see that if a bug is discovered in production, it means that, of course, shit happened. Sorry for that, because you delivered a bug in production, it made into production, it created havoc. I don't know, a bank lost transactions or something. Money were lost. Probably credibility was lost as well. And you, as a development team, you have to provide a patch, of course, as soon as possible. So the cost is enormous. The earlier in time that you discovered bugs, the less costly it is. And unit integration testing are there to make you actually help in identifying bugs as early in development as possible. Not only that, but as I said, they have an extremely short feedback loop. Now, if you are a developer and you are doing unit tests properly, you can be sure that as soon as you enrich your code with new functionalities and maybe you break something, there will be a unit or an integration test telling you, look, man, you have broken that code. Don't commit it or I will kick you in the nuts. In a sense, unit and integration testing, they help the team building trust in what they are doing, because it feels extremely good to see all those green tests successful. And believe me, it feels equally good to see that some are red, because it means that, yes, you have broken something, but you have total control on what you are doing. To be honest, me personally, if I happen to develop anymore in the future, I would feel not comfortable to work for an application that is not backed by unit and integration test. Basically, I would fear to get my code better because I may be breaking something. Of course, as I said, unit integration tests are not the only type of test that developers are doing during the daily work, I'm sorry. They are normally completed by end-to-end tests. End-to-end tests, of course, they are absolutely precious. They are more expensive in the sense that they are slower. They normally are more complex to put in place. So this pyramid tries to give you a sense of the quantity in proportion of how many unit integration and end-to-end tests you should put in place. This is nothing new, actually. The testing pyramid was conceived by Mike Cohn, who is one of the contributors to the Scrum software development method, and he's also one of the founders of the Scrum Alliance. They also act, meaning unit integration test, as live documentation. You maybe know, guys, that especially if you have some developer experience, you can comment your code, technically comment your code to just make it more speaking, to make in a way that whoever is reading it understands what the code is doing. You can do it via comments, but remember, you have to keep comments in line with logic. Sometimes that's not done. Logic changes, comments are the old ones. So there is Ron Jeffries here, who's also one of the contributors to the Scrum method. So a very important exponent in IT. He said once a very, very interesting quote: code never lies, because code is logic. Comments sometimes do. Prefer good unit integration testing to comments, or at least make them integrating comments, because if a unit integration test is written as it should, sometimes it's also written in a functional way, so very close to human talk. That's what should tell you what your code is doing. So this is a good secondary benefit, if you want, 2-unit integration tests. Take a think. Last but not least, they are the roadmap to customer satisfaction. And I invite you to see at this, which is a very simple, let's say, roadmap to how you can get from unit integration test and improve from them the customer satisfaction. Of course, customer satisfaction requires as a prerequisite high quality. Okay, so there is no way around it. High quality requires you to take control over technical debt. And to take control of technical debt, refactoring is required. And to be sure that refactoring is successful and doesn't break anything, you need unit integration testing. Now, I know you may not be familiar with those two terms. So that's why I'd like to open a parenthesis here and spend some time about those two concepts. Technical debt. So, think about a kitchen and think about you having dinner with your family. At the end of the dinner, you may be deciding two things. You take care of the mess that you created while preparing cooking immediately. You load the dishwasher and you clean, I don't know, your kitchen table or whatever. Or you can also go the procrastinate way, which means you just leave things as they are and you take care later of them. Now, this could make sense. I mean, you can win some time and spend that time for more amusing activities, like watching TV or doing some sport. Of course, so the benefit in the short term is clear. But next time that you will be having dinner and you get your kitchen even worse than that, you have to clean it up basically twice. And the next time you will have dinner again, probably you won't have any more dinner because the kitchen is completely unusable. This is technical debt. Technical debt in IT is similar to that in that you start your application, then your requirements change, which is very common. New features are added over it. Bugs are fixed, sometimes quickly, in order to get to production quicker. So this is actually the similarity with the fact that you just don't clean up your kitchen. You just fix and have dinner the best way you can. Some developers could go and come. So quality is not even. Some developers are more experienced, some other are not. So, the approach to problem solving may be different. If you don't take care of these, possible culprits, problems continuously, you may end up with an application that is so tangled together, so spaghettified, if you want, that it's probably very difficult to add anything else over it. I like to compare the technical debt to rich application with a house which has so, let's say, clumsy basement, and it is so badly done that even by adding a new window, it may risk the house to be crumbling down. Trust me, I saw product owners super busy adding new features over features over features without giving developers the necessary slack for controlling technical debt. Then when they realized actually that their application was like a house of cards, basically built upon a very slippery table, and the adding of a new features was breaking another existing feature, they were desperate. And only at that moment, they did realize what technical debt is. Only that it was too late. Too late in the sense that at that time, the cost of fixing technical debt was much, much higher than if they had taken care of it continuously. If you want another analogy, it may be that technical debt is a little bit like financial debt, where the more you wait to pay it back, the more interests you pay. Now, I believe you have quite a good understanding about what technical debt is. How can we take care of it? Well, the bigger weapon that we have for taking control of technical debt is the so-called refactoring. Basically, refactoring is a fancy word to say we want to improve our code structure and have new features, for instance, better integrated into the existing architecture without just putting them the quicker we can. Hopefully it will work, hopefully not. So that our code is made easier and easier to read and understand, not only by people that wrote it, but even by people that are supposed to maintain it. In a way, this is facilitating a lot the integration of new features, all while not changing the external behavior of your application. So this is the key concept. Refactoring is getting your code better because you have in mind better solutions, okay, without having your application as a black box from an external point of view, changing its behavior, because we don't want to break the way it behaves for the end user. And the only way to guarantee that is to have your code backed by unit and integration testing. So here we come again to the concept. They are the policemen, if you want, to your quality. As simple as this flow is, this is a very exemplification about how refactoring should be done. The developer starts and he makes a small improvement, okay, because he believes that that code can be done better, okay. Then he runs all the tests. Now you can have two outcomes here. Your test passed, in which case you go on with the next improvement, okay, or you can decide to call the session over. Or your test may be failing, which is not the end of the world. Absolutely not, because you know that you are covered. So before continuing with anything else, you take care of either fix what you have done and run the test again, or you just revert because you have done, you're not confident with it, and that's it. You can pass to the next improvement, or you call the session over. So small improvement, run the tests. Small improvement, run the tests. There is a saying in programming, if it works, don't touch it. I couldn't agree less with it, because this is exactly the way you get your application failing in the long term. Instead, you should think about your code as an asset that you have to create, and think about the fact that the person that is going to maintain it is an assassin, a murderer, or something. So try to make him happy, which means try to have the best quality as possible in what you are doing. Or less prosaically, I would say, reading is sometimes, most of the time, I would say, more important than writing. Now, the question is, when to start doing unit and integration tests? The answer is extremely simple from the start, from the get-go, from the beginning, because it must be an habit. You can be sure that if you delay that, there will be always an excuse for you not to start. In a way, because development is normally always under pressure. The product owner is, of course, understandably, okay, interested more in adding new features rather to give you the time to integrate them well into the system. But he must be aware of it. The key is that unit integration testing is development. It must be an essential part of your development effort. Again, I repeat myself, but think about the bricklayer. It's inconceivable to have the bricklayer checking if the bricks are aligned at the end of the building of the wall. Because if there is a problem, of course, he has to start from scratch again. So this is an activity he does continuously. The same goes with IT, with an application to be developed. And to have this happen, it's absolutely important that the product owner or the managers, for that matter, they understand the importance of unit integration testing, and they give the necessary budget to the development team to actually do it. So it must be estimated together as the implementation of the features and give it as much importance. At the end of the day, it must not be considered a burden, because it's not. It's a priceless tool. Even some developers misunderstand this sometimes. I work with teams that they just told me, we don't have time to do unit integration testing, as if it has no importance. It is a priceless tool that we cannot basically overlook it. Now, guys, a little bit about what are the most common and effective testing principles when you put in place unit and integration testing. Simply put, it must be backed by automation as much as possible. Okay, and this is done in many ways. It is very prone to automation, by the way, because unit integration testing, being very close to development, it can be, part of it. And it's also, normally unit integration tests are very simple, very isolated. So they are a very good candidate to automation. And by automation, I mean that a machine must take care of it. It's important that unit integration tests can be run onto the developers' machines, of course, but most of the time we also offload the burden of executing unit integration tests to some dedicated machines. Probably you have heard about DevOps and continuous integration pipelines. The main advantage of automation is that it's not error-prone, of course, as long as the tests are correctly written. Unlike humans, the execution of those tests is not error-prone. Instead, if you rely too much on manual tests, you may be entering the day of dropping production where one or two developers didn't sleep any good during that night. They are not in shape, and they just overlook a couple of bugs. Okay, that is very human. And automation prevents that from happening. Also, automation, of course, is available 24/7. It's a robot. Automation must be configured in a way that the campaign of unit and integration test starts as soon as the smallest bit changes into the code base, so that we are sure that what we have changed is working or not. It's true, it's initially expensive. There is no way around it. You have to probably, I don't know, even train people because maybe they are not used to it. You have to pay, of course, for hardware. You have to pay for the configuration of that pipeline. So yes, it's expensive, but it pays off. There's no way around it in the mid run, not even the long run. It pays off. And this is unfortunately many times misunderstood by many managements. They must be absolutely easy to run. So they have to be backed by convenience. They have to be easy to run. They have to run fast, because if they don't, they won't be run by developers. They won't. They know that it will take half a day to run my campaign. I won't run it. So that's not the good way to do that. They must fail fast. So as soon as there is a problem, the unit or integration test must be solid enough to tell you as soon as possible, look, I stopped the campaign because you broke something. Immediately. They must be repeatable. And to be repeatable, they must be crowned, let's say, by the factor of integrity. So they have to be solid in a sense that if they have the same input, no matter when or how they are run, they have to provide the same outputs. If they are not, it means that they are dependent on some other things, such as dependence on data, dependence on the system where they are run. So they are not solid in this sense. Don't test only what you do expect the system to answer you. Remember the rubber ring and the shuttle. That rubber ring failed because of one reason. It was not tested against the frigid, the unusual cold temperatures in Florida of that morning. It was tested for temperature in between 10 to 20 degrees Celsius. That morning was 3 degrees Celsius. It was not tested against that. Similarly, in IT, if we get back to our very small example where two strings are given to input into our method supposed to divide them, don't just input in your test 18 and 6 and expect a 3. Okay? Try to give your method some alphanumeric values instead of numeric values and see how it behaves. Try to give him the null value or an empty string or an extremely big number. These are called the edge cases. So you well understand that one unit can be tested, should be tested by several tests. They must be structured in a way that it's when it's like when you go to the toilet. Leave the toilet, the same let's say situation, the way you found it, basically. So clean. The unit test itself must have let's say a phase of setup where it's probably feeding the data that are needed to the system for it to be tested, then an execution where the actual test takes place, and then before ending up, a clean, a tear down phase must take place in order that the next test is not affected by what your test have just done. So in a sense, they must be as isolated and independent as possible. Now, a small word about what does isolation means. Remember our car example. You may have a simple unit such as the fan that has no dependencies whatsoever. So that's very easy to unit test. But you may have a subsystem where the crankshaft, okay, for example, is very much depending on, well, it's not depending, it's more, it has to work together with the pistons. So you have to give a boundary, okay, to your test in order that you can run no matter how. In this case, of course, crankshaft and pistons are an integration tests, okay? Sometimes part of the unit that takes part to this integration may not have been developed so far. In that case, it's a good practice, it's a common practice to mock those interfaces. So even though in this example, the pistons are not done yet, you should have their specifications, mock the pistons based on those specifications, and run the integration test with that. Final word about code coverage. The definition of code coverage is the degree to which the source code of your program is covered by tests. Well, many times I heard these people posing this question: how much coverage should my application have? Well, look, it's a kind of difficult question because this answer is as much as possible, of course. But as much as possible doesn't mean that you have to test even trivial code. Okay, there are some code in IT, such as the so-known getter and setters. They are so simple in their logic, they just have to return a property. I mean, what is the point in testing them? Okay, try to have a good balance. High coverage, I would say at least 90%, 85, 90%, but be reasonable. All right. Of course, if your method gets more complicated, it may be needing an additional test. So take care of that as well. There are ways today to have the coverage displayed continuously into the development room for developer to check it continuously. There is a platform which is called Sonarcube, which is there exactly for that. It's a dashboard, a very simple one to understand, but it's a very powerful one. Look at that. In this case, you have your application benefiting from 90% of coverage and 80,000 unit tests. For yeah, the coverage is quite high here. Sonarcube does not only that; it does many other things. A very powerful tool that I invite you to explore. It takes care of code smells, which is also bad practices when you put in place your code, whatever. Anyway, coverage is very important, but beware coverage bias. What does it mean? It means that test coverage measures only which code is executed by your test, but it does not check that your tests are actually able to detect faults. Okay? That is test quality is different. Test quantity, which is the coverage, is not the same as test quality. Your Sonarcube or your continuous integration pipeline may tell you that all of your tests are successful with a very good coverage, 100%, and then you go deeping a little bit into the code and you discover that your tests are just stupid. Okay, look at that. These are three tests calling a method supposed to be tested, method 1, method 2, method 3. It's called, and then nothing is checked. Basically, that means that the result of the method is checked against the same result. It's a tautology, which is useless. So beware the testing coverage. Actually, there are techniques today to be sure that you also have test quality. The most used one, and Gilles here is a very expert on that, it's the so-called mutation testing. Now, I'm not going to talk about that because I would open too big of a parenthesis. But basically, mutation testing, it's very clever. It changes your production code on the fly, and it expects your test to fail if you change that code. If your test doesn't fail and keep being green, well, it means that it's very weak. Okay, we are leaning towards the end of the presentation. We're quite in time, even though it's a bit late probably. So I will go through maybe a conclusion. In a nutshell, remember this simple chain. Quality requires technical depth, which require refactoring, which cannot live without unit integration testing. Even more simpler, as a manager, would you more trust someone telling you, yes, we can release because we have made some manual tests and it seems okay, so let's go for a release? Or you more trust a system, actually, that tells you that is covered continuously by unit integration test. The last run was 5 minutes ago. 500 unit and 140 integration tests were executed, all passed with a good coverage. Let's release. Okay, who would you trust more? Try to ask yourself that. Now, let me just finish with a final note. Test code is no different than production code. Well, yeah, of course, the goal of it is different, but you have to take care of it with as much attention as possible, at least as the same that you give to production code. It is the guardian of quality and the policeman to prevent misbehaviors from the very beginning. In a sense, it's important for the developer and for business people and for manager alike, where the former, so developers must strive to get it right, and the latter must give the necessary room to implement it. And by room, I mean enough time and enough budget. And with that, our presentation is over. A little bit of bibliography here of some maybe interesting posts that could be interesting. Actually, I invite you to have a look to the first one, which is a true story about how ignoring technical debt nearly got a bank reputation disrupted. It's a very funny, in a way, story, even though it's tragic. I invite you to have a look at that. And with that, we are at the question and answer session. Thank you for that and for the attention.
Yes, we already have some active participants asking questions in the chat. Let's start with the first one. When is the appropriate time to do integration testing? During the sprint or before the release?
During the sprint, any sprint. That's how unit integration testing, must not be detached by development activities. If you create big phases, you create a wall. And that wall is just preventing you from discovering problem in quality. So integration testing must be part of the development of any feature. And it must be actually live with the development of the feature itself. It's bad to have it at the end of the, it's extremely bad to have just before production, of course, but it's also bad to have, and I experienced that with some teams, they have some sprints dedicated to testing only. That is bad as well. So you do your sprint, and within the sprint, you do all necessary activities to get your feature done. Remember that unit integration test is part of the should actually be part of the so-called definition of done. And the definition of done is the driver for quality. So one of the line of the definition of done for the development of any feature should be, I have covered my code, with proper unit integration testing. They must be of high quality and they must be running green. Okay.
Next question. Do the integration tests have to be done by whoever developed the components? Who should design the cases for the automated tests?
So if I understand the question correctly, the question is asking who is supposed to put in place the code for unit integration testing, right?
For the tests, yes, that's how I understand it as well.
So the simple answer is the developer himself. Look, it's a bold statement what I'm saying, because many people say that if the developers is the same as the developer that did the development, he may incur in some bias and testing only what he thinks is working, which is kind of true. But this is applicable only to classic tests. If instead you have a good process for checking the quality of unit integration test and development, and this code is undergoing a review by some other people inside the team, that's perfectly acceptable. Okay, this is a way to keep quality, not only your development code, but also into your unit integration testing code. Okay, so it's acceptable, actually recommendable to have the same developer writing the tests, but then it's a good habit to have some other people of the team, some reviewers, to take care and judge the quality of what that developer has done.
Okay. Next question. Assuming success of integration testing, is that a green flag for behavior-driven development or feature-driven development or both?
Look, this is a very specific question. I think they are not related to behavior-driven development at all, because they are very much related to the production code, so to actual code. So I would actually take the behavior-driven development out of the discussion here, because yes, they are perfectly compatible with that. But even though you don't put in place behavior-driven development, you do the very same. What I'm answering here is, the question says, is the success of integration test a green flag? Well, that's a very good question, because I tricked a little and I oversimplified one slide, which is this one. As I said, unit integration tests should be completed by user testing, by end-to-end testing. Why is that? Because they are low level, okay? If there is a failure on one of the integration tests and you haven't done end-to-end testing, it's quite difficult to understand what feature you have broken. So the normal chain is unit, integration tests, and end-to-end tests. They must be completed by them. Actually, end-to-end tests, they answer testing from a different perspective, the user perspective, which is as much important.
Don't you scan the code for quality is part of this question at the end.
Yeah, and in fact, to complete a bit this question, because I contacted the person, how the scan code could contribute to improve the quality?
The scan code? Sorry,
to scan the code.
To scan the code with the tools like Sonarcube and so on. How this could improve to get better quality on the code itself and also on the quality globally of the software of the component.
Look, Sonarcube is, as I said, it's quite a powerful tool because not only it takes care of telling you how much coverage you have in terms of unit and integration tests, but it provides you also a view about how much of a code smell do you have. And code smell is problematic code, okay? Sonarcube is relying its judgment on some rules that you can use the default ones. You can even inject your rules. Some rules can be, for instance, your method is too complex. It has too much of a cyclomatic complexity, which means it is too much nested with a lot of ifs and for loops. So that could fail Sonarcube judgment. In that case, Sonarcube is telling you, look, that method probably is really too difficult to understand to people. You better do something about that. So Sonarcube is your friend when it's up to judge the quality and by consequence, the amount of technical depth of your code, okay? Of course, as I said, it can also be configured with specific rules for your application needs and your sentiment about what quality is, of course.
We have a couple of more questions. Would you like to continue, Davide, and answer them?
Yeah, why not, if you have time. Yeah.
Great, thank you. How to influence management to invest money on testing in a situation where costs are hunted like witches?
Are handled like?
Hunted like witches.
Yeah, that is a very common scenario, actually. I love this question. Look, I mean, I think you have to go, if you have failed in convincing them with reason, okay, it's sad to say it, but I believe that you have to scare them a little bit. And you have to put forward examples of real situations where disregarding, overlooking quality led to disaster. And you find a hell lot of these examples in the literature on the internet. I experienced that situation myself in the past, so I can also put forward situations that affected me. You have to tell them, guys, give them the, okay, look, give them the example of the kitchen, first of all, okay? And then you see how it goes. Then you put forward this example. How ignoring technical debt nearly destroyed a bank's reputation. That post in Medium contains probably whatever you need. It's very speaking. If you still fail, you know, it's their responsibility at the end.
Let them learn by doing.
I would say so.
Thank you. Do you have any recommendations for carrying out refactoring and automation for legacy or technical applications?
Sorry, I didn't understand the first part of the question.
Do you have any recommendations for carrying out refactoring and automation for legacy applications or all technical?
Yeah, this is the most complicated scenario, because if you have a legacy application, of course, you have to face a situation where the problem is already present. Okay. So for instance, you may be in the situation where there are mostly no unit or integration tests present, which is bad. It's extremely bad. Look, what you can do is to go bit by bit. So if you go the big bang way, it will be failing. So what you do is you reserve some time during your sprint, for every sprint, to 1, assess the situation of your application, B, decide what to do, C, put in place a small percentage of coverage of unit and integration tests in order that sprint by sprint, you get your legacy application code back on track. Once you have enough unit and integration tests to cover your legacy code, at that moment in time, you are in a more comfortable situation. Why is that? Because you can start improving your code. You can start make it not anymore a legacy application. Why is that? Because you are covered by unit and integration tests. I know, easier said than done, but I don't see any other way.
Okay, thank you. And one last question, how do you make a business case for quality? Is it possible to show how much monetary costs of quality is leading to what return of investment? Or are there any guidelines in this regard? As we see, it's required, but it's sometimes not possible to quantify this in a good way and get the approval.
So this question is asking, how can we quantify the investment we have to do into refactoring?
The quality will lead for what return of investment?
Well, I think that very much depends on the application itself. So, I mean, in the initiative project itself, it's yeah, I know it's difficult because we're starting from a technical topic, which is actually, you know what, the problem is that the actual advantage of unit integration tests are not immediately apparent. They are just a tool that serves you to get your code better. Quantify that, it's very difficult, to be honest. The only thing you can do is to raise awareness and proceed by examples. Try to speak the same language of the people that you want to convince and go that way. If you start quantifying the advantage of unit integration tests, you start from a hell of assumptions, to be honest. They may be wrong, they may be good, but you're never sure that they are realistic.
All right, thank you for that. With this, we are approaching the end of today's webinar. I think you won the prize for the most entertaining and metaphorical webinar we've had this week.
Really?
Everyone enjoyed the comparisons.
Metaphorical, okay. I can do the psychiatrist one.
No, it was put in such a form that it was digestible for all of us, even for people with not so deep technical background.
Very much appreciated. Thank you.
For the participants. Let me quickly share the PDU code for today's session.
Yeah.
With everyone. There you go.
I can't see anything, to be honest.
Maybe you have to share your screen. I just pinged it in the chat if necessary.
I am.
I have to stop my sharing.
Yep,
okay.
That's it. That's why. Now it's going to come for you, Margarita.
Yeah, I can
slowly. Slowly. Just a second. Technique is not cooperating. Apologies for that. But there you go.
One more time, thanks a lot to our sponsors for this Agile Week. And also for all the for your participation also, Davide, and
you're welcome. Thank you for the opportunity.
Okay, so now we can see the PDU code, and you have also our sponsors, Intrasoft, Alvision, which are pretty supportive for this Agile Week, and all our other sponsors like PwC, Deloitte, and I forgot the other ones. We have EY, and what are the other ones?
Chambre de Commerce. And Chambre de Commerce.
Yeah, thank you for that.
The recording will be available on our webpage. Follow us on social media to get news about the Agile Week and also about the slides from Davide. You will be sharing it with the audience, right?
Oh, yes, absolutely, yes.
Thank you for today's session.
Yeah, thank you for the opportunity, guys.
And have a lovely day.
Yeah, likewise. Goodbye.